Logging onto the console of a server, either physically or by means of a remote desktop connection, is a poor management practice. Sometimes it is unavoidable, but having a server generate and maintain a graphical user environment, your desktop and the applications you run on it, is a poor use of server disk, memory, and processor resources. Microsoft has gradually added remote management capabilities to many of the administrative tools and consoles that administrators use most, including Active Directory users and computers, Server Manager, and so forth. However, these are usually graphical tools, meaning they can be easy to use, but they cannot be easily automated. With Windows PowerShell's remote management capabilities, you can run nearly any Windows PowerShell command and have it execute on one or more remote computers. This capability enables you to manage remote computers more easily and with less overhead than a console session or a remote desktop connection. Remoting is designed to provide connectivity between two or more computers. The client is the computer where you physically sit. Remote computers are those that you manage remotely by using Windows PowerShell. Rather than using older protocols such as RPCs to communicate, remoting uses Windows Remote Management, or WinRM. WinRM is a Microsoft implementation of Web Services for Management, or WMI, a set of protocols that has been widely adopted across different operating systems. As the name implies, WMI, and thus WinRM, uses web-based protocols. An advantage to these protocols is that they use a single definable port, making them easier to pass through firewalls than older protocols that randomly selected a port. WinRM communicates via the Hypertext Transport Protocol, or HTTP. Note that the version of WinRM included with and used by Windows PowerShell v2 does not use ports 80 or 443, the traditional ports used for HTTP, by default. By default, the current version, 2.0 of WinRM, uses TCP port 5985 for incoming connections. This port assignment is configurable, although leaving it at the default is recommended since Windows PowerShell's remoting-related commandlets assume the same default port. WinRM runs as a service. When enabled, and provided that the necessary firewall ports are opened, the WinRM service listens for incoming WinRM requests on its assigned port. When a request is received, WinRM examines the request to determine which application the request is meant for. Applications must register an endpoint with WinRM. Registration informs WinRM that the application is available and capable of processing incoming WinRM requests. This registration is what enables WinRM to find the application when an incoming request is received for that application. When an incoming request is received, WinRM passes the request off to the designated application. The application does whatever it needs to do, and then passes any results back to WinRM. WinRM then transmits those results back to the computer and application that sent the original WinRM request. Windows PowerShell does not, by default, register itself as an endpoint. Again, this is for security purposes. You must explicitly permit the shell to register itself as an endpoint with WinRM. This can be done locally for a single computer or by means of a group policy object in a domain environment. You must also ensure that any necessary firewall configurations are modified to permit the WinRM traffic. For security purposes, WinRM is disabled by default and must be enabled. It can be enabled locally on a single computer or can be enabled and configured by means of a group policy object, GPO. Once enabled, WinRM must be configured to allow applications like Windows PowerShell to register to listen for incoming connections. Also, your local firewall needs to allow the proper traffic on the specified port. WinRM can use Transport Layer Security, TLS, sometimes referred to as SSL, to encrypt the data being passed across the network. The individual applications that use WinRM, such as Windows PowerShell, can also apply their own encryption to the data that is passed on to the WinRM service. WinRM supports authentication and by default uses Active Directory's native Kerberos protocol in a domain environment. Kerberos does not pass credentials across the network, and it supports mutual authentication to ensure that you are really connected to the remote computer you specified. WinRM and PowerShell Remoting require all involved computers to be running Windows PowerShell 2, which requires the Microsoft .NET framework. Version 2 of the WinRM service is also required. This ships with Windows Server 2008 R2 and Windows 7, and is included in the downloadable Windows PowerShell version 2 installer for older versions of Windows. There are two ways to configure Windows PowerShell and WinRM. The first, and perhaps easiest, is to run the Enable PS Remoting commandlet. Avoid running setWS-man quick config. This commandlet does configure a portion of remoting, but not all of it. In fact, Enable PS Remoting runs setWS-man quick config internally, and then performs the other actions needed to register Windows PowerShell as a WinRM endpoint. You will typically configure remoting not on individual computers, but by means of a group policy object. This defaults to Kerberos authentication and permits you to centrally configure whatever computers you like. When remoting is enabled between domain computers, no other configuration is needed. Thanks to Kerberos, the computers automatically trust one another. Here is the group policy object setting that is used to configure WinRM. Nearby, you will find the Remote Shell GPO setting. For now, let's just enable remoting for this individual computer by going to a PowerShell command window and running Enable PS Remoting. Note that this command is machine-wide. We are configuring the computer, not PowerShell itself. Connecting in a non-domain environment is more difficult because the computers involved do not share a common basis for authentication and trust. Windows PowerShell's built-in help files provide guidance and step-by-step commands in case you ever need to configure this non-domain or workgroup remoting connectivity. One of the big problems you can run into with remoting is when you're not running the shell as an administrator on your local computer. This can be especially easy to do when you're using User Account Control, or UAC. Be sure to right-click the PowerShell icon and run it as administrator to ensure the shell has the proper privileges. Also note that remoting only needs to be configured on the computers that will accept incoming connections. Any computer with version 2 of PowerShell can initiate connections without further configuration. Be sure that the WinRM service is set to start automatically. This is the default on server operating systems, but the service is disabled on client operating systems. Enable PS Remoting will configure the service properly and start it. If you are configuring remoting by means of a group policy object, you can use the Set Service commandlet, providing a computer name or list of computer names to reconfigure the WinRM service on one or more remote client computers. Set Service itself does not rely on WinRM, so the command will work even if the WinRM service is not yet running. If you need to deal with any of these situations, review the About Remote Troubleshooting help topic within Windows PowerShell. This help topic provides additional guidance and specific step-by-step instructions for each of these scenarios. One-to-one shell enables you to get a remote command line prompt, similar to SSH or Telnet in a Unix operating system. One-to-one shell is also similar in function to the way PSExec works. Once you have opened a one-to-one remote shell connection, you are effectively using the remote computer's Windows PowerShell session as if you were physically sitting in front of the computer and open a Windows PowerShell window. Use Enter PSSession to establish the remote shell connection. This commandlet accepts a computer name parameter, which accepts the name or IP address of the computer you want to connect to. Other parameters enable you to specify alternate TCP ports, specify alternate user credentials, and so forth. Read the help for the commandlet to learn about these and other capabilities and features. Once the remote shell session is active, your Windows PowerShell prompt will change to indicate the name of the computer you are connected to, as well as the current path. When you are done using the remote connection, run Exit PSSession to return to your local shell prompt. When establishing a remote shell connection, remember that profile scripts are not executed, even if a profile script exists. When you are using a remote shell connection, you only have access to the commands that are installed on that remote computer and that you have loaded into the shell by adding Add PS Snap-in or Import module. The commands available on the remote computer may be different from those available on your local computer. Use caution. When you are in a remote shell session, every command you run will be executed by the remote computer. Entering a new session on a remote computer causes the prompt to change, indicating the computer we are connected to. Any commands we run here are run on the remote computer. This is a very low overhead, lightweight means of connecting to a remote computer, and it's even supported by Server Core in Windows Server 2008 R2. When we're done, we just run exit PSSession to return to the local instance of Windows PowerShell. Doing so closes the connection, and the remote instance of the shell will shut down. One-to-one remoting is useful when you only need to run commands on a single remote computer. However, if you need to run the same commands on multiple remote computers, using one-to-one remoting is inefficient. You have to enter a session on the first computer, run your command, and then exit. Then you enter a second session, run the command, and exit. You repeat this process for each remote computer, and it will become overly time-consuming and repetitive. One-to-many remoting enables you to submit a command, multiple commands, or even an entire script to a set of remote computers. The commands are transmitted to the remote computers by means of WinRM. Each computer executes the commands on its own and returns the results, again by means of WinRM, to your computer. By default, the shell will not try to connect to more than 32 computers at once. If you specify more than 32 computers, it will work with the first 32, and then as those complete the commands, the shell will start contacting additional computers. This feature is called throttling, and you can modify the throttle level by means of a throttle parameter. Using one-to-many remoting is accomplished by means of the Invoke-Command commandlet. The commandlet accepts whether a script block or the path to a script file, and can accept one or more computer names. Additional parameters of Invoke-Command enable you to specify an alternate TCP port, specify that encryption be used, specify alternate credentials, and so forth. Review the help for the commandlet to learn more. Invoke-Command is used to run a command against one or more remote computers in parallel. A command line parameter throttles the number of computers that are connected at once, with a default of 32, to help ensure good performance. This command runs synchronously, meaning the shell will pause and wait until all commands complete before returning us to a command prompt. The results could be captured into a variable, piped to another command, or as shown here, simply allowed to display on the screen. Invoke-Command accepts pipeline input by property name for the computer name parameter, and can also accept simple strings for the computer names. Here's an example of how you might use that. I've created a list of computer names which might represent a certain class of computers on my network, such as web servers or domain controllers. I'm retrieving those computer names from the file and passing those to the computer name parameter of Invoke-Command. This invokes the command on all of those computers. This is a very powerful technique that can replace several lines of more traditional script code. Keep in mind that Windows PowerShell commandlets return objects as their output. Unfortunately, software objects cannot be transmitted across a network. Instead, WinRM serializes the objects into an XML format, since XML is just text, and text can be transmitted across a network quite easily. The objects are received by your computer and then deserialized back into objects. This conversion to and from XML does have an impact on how you can use the objects. For example, when objects are received from a remote computer, those objects' methods are no longer available, excepting a built-in toString method that is attached to all objects. Only the object's properties have survived the conversion to and from XML. These objects are no longer attached to real functioning pieces of software. Instead, they are essentially a text-based snapshot or representation of those objects. Also note that a few additional properties have been attached to the objects. PS computer name, for example, which contains the name of the computer that each object came from. When you are receiving results from multiple computers, this additional property can enable you to sort and group the objects by the computer they came from. Here is an example of using the PS computer name property to sort and group the results of Invoke-Command. Having access to the computer name right on every object is a very useful way to sort, filter, group, or export the results. Invoke-Command has a few other neat tricks. -command is an alternate name for the script block parameter, which is where you specify the command you want to run on the remote machine or machines. Both accept a script block, which is one or more commands enclosed in curly braces. Alternately, you can use the -file path parameter to specify the path and file name of a local script file. The commandlet will then copy that script to the remote computers, which will execute it. The hide computer name parameter suppresses the PS computer name property in your output. Although that property remains available for sorting or grouping, it's just hidden from the display. The help file for Invoke-Command explains more about these and other options. Thus far, you have specified connection information for both one-to-one and one-to-many remoting. That is, when running either Invoke-Command or Enter PSSession, you have provided computer names and possibly provided port numbers, alternate credentials, authentication options, and so forth. Having to do so over and over and over can be repetitive and error-prone, so Windows PowerShell offers a way for you to create and reuse connections. The shell provides this capability through something called a PSSession. You create a new persistent connection by means of the New-PSSession commandlet. Its parameters are similar to those of Enter PSSession and Invoke-Command. You specify computer names, credentials, ports, and so on. The result is a persistent session object, which can be stored in a variable for later use. The shell maintains the session for as long as the shell window is open. Closing the shell automatically closes the connections. Session objects can be passed to both Invoke-Command and Enter PSSession, although Enter PSSession only accepts a single session object. New-PSSession has numerous parameters that can customize the port used, the authentication mechanism, alternate credentials, and so on. You should review the commandlet's built-in help for more information on these and other options. Sessions do require some memory, processor, and networking overhead, so you should not leave them open without need. Use the Remove PSSession commandlet to close sessions, and use Get PSSession to retrieve sessions that are currently opened. In environments where you constantly have to provide non-default values for port numbers, credentials, or other connection parameters, sessions can save a lot of time. This command is creating a new set of sessions to a group of computers. Note that the computer names are being read from a text file that contains one computer name per line. The resulting sessions are stored in the sessions variable. That variable can then be passed to Invoke-Command, enabling it to run without us having to specify the computer names or other connection parameters again. When we're done using those sessions, we can pipe them to remove PSSession, closing the connection and releasing the memory being used by those sessions both on our local computer and on the remote machines. A final application of remoting is called Implicit Remoting. The idea here is to recognize that different computers in your environment will contain different commands. For example, a domain controller may contain the Active Directory module. That module will not run on a Windows XP client computer, although Windows XP can have Windows PowerShell v2 installed. Suppose you have a Windows XP client computer and you want to use the commandlets in the Active Directory module. Implicit Remoting provides a way to do so. The basic steps involved are as follows. Use New-PSSession to establish a session from the Windows XP computer to the domain controller that contains the Active Directory module. Invoke a command on the domain controller to load the Active Directory module. Use the Export PSSession commandlet to export the session to a module on the Windows XP computer. Specify that only commands whose nouns start with AD be exported, thus ensuring that only the Active Directory commandlets are included in the export. Close the session to the domain controller. This process creates a local module on the Windows XP computer, but it does not install the Active Directory module on the Windows XP computer. That module can't run on Windows XP. To use the Active Directory commandlets, import the created module, specifying a commandlet noun prefix to help remind yourself that the commandlets are actually running remotely. You can then execute the remote commandlets by specifying their normal commandlet name plus the noun prefix you specified. The first commandlet you try to run will engage the remote WinRM session to the domain controller. The commandlet will run on the domain controller and the results will be sent to your computer via WinRM. After running one commandlet and engaging the remoting session, you can use the help command to retrieve the help files for the remote commandlets. Of course, implicit remoting works in any scenario where you want to use the commandlets installed on another computer. You aren't limited to the Active Directory module or to Windows XP, although that is a good example of how implicit remoting can be useful. Let's say I'm working on a computer that does not have the Windows Server 2008 R2 Active Directory module. If I try to run New AD Computer, I get an error. So I will create a session to a computer that does have that module. I'll have the shell on that remote computer load the module into memory. Then, I will import that session to my local computer, grabbing only those commands from the Active Directory module. Notice that I'm specifying an additional noun prefix for these commands, just to help myself remember that they are really running remotely. What I have on my local computer now is a set of pointers to those remote commands. That means those commands are available to me locally. When I try to run the new AD user, for example, the shell will reuse the existing remote session, execute the command on the remote computer, and return the results to me. In this case, it is actually prompting me for a parameter that I forgot to specify, just as if the command were running locally. In fact, once that remote session is up and running, I can even ask for help on a new AD user, and the help will be retrieved from the remote computer and displayed here. This is a great way to run commands that may be located on other computers in your environment, including commands that, for compatibility reasons, cannot be physically installed on your local computer.